All right, so something strange happened on the last particular lesson. I don't know what it was, but I'm staring at my screen right now that it's projected on, that I stare at every single video I always do. And up always pops this entire screen of information. And on the last one, for whatever reason, there's this is a screen on a monitor that I'm looking at. And on the last one, it was like the screen on my laptop, and it doesn't usually work like that. In fact, it never works like that. So I don't know why that happened. Hopefully on this video you're seeing an entire screen. Chapter 5 is basically the chapter number for the statistics that we're going to cover. And today is all the fundamentals of statistics. It's really a lot of definition sort of stuff. It's not a lot of math that we're going to cover today. It's almost kind of like the last chapter where there was less math and more understanding. That's what we're going to do right now. Okay, so the fundamentals of statistics. Statistics is the science of collecting, organizing, and interpreting data. If you're into sports, boy oh boy, all of this stuff that they use now about analytics is a fancy word for statistics. Statistics are the data that describe or summarize something that's going on. Now, the elements in a statistical study, and it's important that you understand that, where you start is always to identify the goals. What's the purpose of this data? What are we doing with it? And it always begins by talking about a population, and a population is like everything or everybody. So for instance, in a presidential election in the United States of America, the population is every single person in the country. But when you see polls coming out, they don't talk about they don't call up every person in the country and say, hey, who are you going to vote for? Instead, what they do is they take a sample, and a sample is a piece of the population. Hopefully it's a representative sample, but it's a part of the population, a subpopulation, if you will. So the sample is taken from the population. It's a smaller group of it. And then the next thing you do is you get statistics based on that sample. See, it's unrealistic to call every person in the United States and say, who are you going to vote for president? But if you limit the sample to 5,000 people, then you can call them up and you can say, hey, who are you going to vote for in the election? And now you've gotten a statistic because it was taken from the sample. And then what they do is they take the statistic and they bring it in to become what we call a parameter, and a parameter applies to the entire population. So a population in a statistical study is the entire group. So that's the big thing you have to remember. The population is the entire group. The sample is a part of the entire group. So for instance, if you were in a high school and you wanted to see what the most popular kind of music in the high school was, you could ask every single kid in the high school, but that's a lot. So maybe you just go and pick 50 kids out of every lunch period and ask them. The sample would be the 50 kids. The population would be every single kid in the school. Now, population parameters are based directly on the population, whereas statistics are based directly on the sample. So samples come from statistics, parameters come from the population. So for instance, if you did ask every single person in that high school what music they liked, you would have a parameter. But with a statistic, you only need to ask the people that you asked in a lunch period. So once again, when we do a statistical study, we start with the thing we want to identify. We could deal with the entire population, but usually that's a little bit too much. So we take a piece of the population, that's called a sample. We develop a statistic from the sample, and then we work it back, becoming a parameter that we're going to apply to the entire population. So for instance, the American Institute of Education conducts an annual study of attitudes of incoming college students by surveying approximately 261,000 first-year students at 462 colleges and universities. It's worth noting that there are more than 261,000 first-year students in the United States of America. There are more than 462 colleges in the United States of America. There are approximately 1.6 million first-year college students altogether. Describe the population, the sample, the population parameter, and the sample statistic. So The population is all the first-year college students. In this case, the 1.6 million of them. The sample is the 261,000 freshmen surveyed because that's a piece of all of the college freshmen or first-year college students. The parameter would be a conclusion that would be based on the entire population, whereas a statistic would be based on the sample only. Next up, describe how you would apply the 5 basic steps of a statistical study to this issue. You want to know the percent of high school students who are vegetarians. Okay, since you've done your stop and start, first you determine the percent of high school students who are vegetarians. That's what you're trying to do. That's your goal. The second is to select, and I'm just being general here, you don't have to have these exact numbers, 100 high schools across the country in a way, this is important, that reflects the population of the country. Like, for instance, you wouldn't want to select all 100 high schools in the state of Washington, which is notoriously liberal, nor would you want to, or state of Oregon or the state of Massachusetts, those are all highly liberal states, nor would you want to go down to, say, Alabama or Texas or West Virginia, which are highly conservative Republican type of states, because you're going to get very different answers. So you'd want to select those 100 high schools all across the country in a way that approximates the population of the country. From these schools, you want to select the percent of each school's population to be surveyed. So you want to be fair about it. You don't want to, like, for instance, if you go up to the wrestling team and you ask the wrestling team, hey, how many guys here are vegetarians? There's not going to be many, if any, at all. But if you went to, say, I don't know, the high school PETA club, People for the Ethical Treatment of Animals, well, now you're going to get a lot of vegans. So you kind of try to want to be fair about the school population to be surveyed. Then you collect all of those results and you make an inference about all the high school students based on the results of the sample of high school students, okay? That would be the arrival at a statistic. So there we go. We identified the goal about checking out, see if you're vegan. We developed a sample from the overall population, being as careful as we could be to make it representative. Then we did our sampling to come up with a statistic, and then we come back and apply it to the entire population. So a representative sample, which is what I was getting at before about the differences between the states, is a representative sample is a subset of a population, that's what a sample always is, that seeks to accurately reflect the characteristics of the larger group. For example, a classroom of 30 students with 15 males and 15 females could generate a representative sample that might include 6 students, 3 males and 3 females. You wouldn't want to include all 6. Here's a really good example. In an election, typically, the Democrat Party generally gets a better vote from minorities. So if you were in a presidential election and you polled only minorities and said who's going to win the election, they're usually going to say the Democrat candidate. And it doesn't matter if you're talking about president or a governor or a local race. It makes no difference. Whereas if you were to not sample any minorities, you would probably get a different answer. So what you want now, and what I said was just extremely general. It's not completely true. You can even go a little more specific and say minorities in urban areas tend to vote strongly Democratic. Minorities in non-urban areas tend to be far more conservative with their voting. In fact, if you look at the country, in any election, Democrats do really, really well in highly populous areas, and Republicans tend to do really well in less popular areas. So if we're going to take a survey, we want to make sure that we don't only ask rural areas or that we don't only ask urban areas if we're taking a political survey. Okay? Here's another example. Let's say you asked for what's your favorite sport. If you were to go up in Canada and ask what's your favorite sport, hockey, eh? If you were to go down to, I don't know, New York City, they might say, oh, come on, New York Yankees, or it's the Knicks. So where you are generally affects what that is. And when we take a representative sample, we want to be fair and make it represent that the sample is the same proportionally as possible to the population. Now, there are some common sampling techniques. Some are simple random sampling. You just pull a name up at random and call them up. There's convenience sampling, where you might say something like, okay, I don't want to really put a whole lot of work into this. I'm just going to go to some place and ask every person. Like maybe you go to the supermarket and just ask them as they're coming in. Then there's systematic sampling, where you say, okay, I'm going to go to a school and I'm going to ask every fifth person I see. And then there's stratified sampling, which means partition the population into at least strata, then draw at least 2 strata, and draw a sample from each. So in other words, you want to divide them proportionally along the lines. For example, what we said about a class that had 15 boys and 15 girls, and when you take your sample, you want to make sure that you have an equal number of boys and girls in that sample. Sorry, I got the hiccups at the moment. All right, next up, you want to identify the sampling method used. So which sampling method are we using here? You're conducting a survey of students in a school, and you choose your sample by knocking on every 3rd classroom door. Just go back and look at this again. Simple random, systematic, convenience, or stratified sampling. I would suggest you take a picture of this for your phone in that math album. So what are you going to get here? Choosing every 3rd room makes this a systematic sample. The sample may be representative as long as the students were randomly assigned to the rooms. But it's definitely systematic because you're doing every 3rd room. Identify the sampling method used again. To survey opinions on a new water line, a research firm randomly draws the addresses of 200 homeowners from a public list of all homeowners. Again, look at that picture in your phone. Which works best? Well, the records presumably list all of the homeowners, so drawing randomly from this list produces a simple random sample. It's a good chance of being representative of the population. Here's an example. You want to determine the mean or the average number of hours spent studying each week by high school girls. Which of the following samples is most likely to be representative and why? Also explain why each of the other choices is not likely to make a representative sample for this study. Go ahead. Okay, so the girls' track team, well, you're asking only athletes who are staying after school and going away on weekends to meets and stuff. So they tend to have a little bit less time. And to be honest with you, look, I taught for a long time. Athletes' grades tend to be better than the average grade in overall, in the sense that athletes or kids involved in anything, it doesn't have to be an athlete. They could be in the play, they could be in the band. When you're involved in things, you know when you get home, you have to get your work done. Kids who are not involved tend to do worse in school. The girls in the advanced placement calculus course, well, those are going to be your extremely intelligent girls who do a ton of work and so on and so forth. So that's not representative of the average girl in the school. The girls in the cast of the current school play, well, having taught for many years, I can tell you that even with your very best students, when kids are involved in the school play, their grades tend to go down because the play requires so much of their time. And I know some people are going to want to kill me for that statement, but it is an absolute fact through 33 years of dealing with school plays as I taught in my class. I would have kids that would be 95 plus students during the semester before, or the quarter before. The quarter of the school play, they would dip down. They wouldn't do badly, but they might get an 88, they might get a 90 or a 91, and then the quarter after that, they're back right up to a 98 again. Or the first 50 girls you meet in the school cafeteria. Well, those girls could be on the track team. They could be in calculus. They could not like to do schoolwork at all. They could be in the play. So that's really general, and that's a great way to get a representative sample. Okay. Bias is where we'll pick up next.